Great. Hello, everyone. Welcome, everybody, to Cranfield University. It is a pleasure to have you here. We've got quite a number of attendees joining us here today, as you can see, but we've got quite a number of attendees joining us online as well. So it's a sort of a hybrid lecture. My name is Kostas Salonidis. I'm Professor of Manufacturing Systems at Cranfield University. I'm also the head of Sustainable Manufacturing Systems Center. At the same time, I'm also the outgoing chair of Manufacturing Industries Division, a board that is basically put together from IMechE in order to support manufacturing not only in the UK, but also globally as well. Today, Ian, who is going to present himself in a few minutes' time, is going to talk about artificial intelligence and how this can actually have an impact on an engineer's career. Ian is basically the new chair of Manufacturing Industries Division, and it's our tradition within the board that the new chair is always delivering this annual lecture, this Alastair Graham lecture, and I think you will be talking a little bit more about this as well. And before I pass on to Ian, I would like to remind you all that at the end of this session, you can ask questions, and I'm sure that Ian will do his best to answer your questions. For the ones who are online, please use the Q&A function in order to ask your questions, and we will make sure that these questions are asked. So on that note, I will pass on to Ian as soon as I make sure that we can actually see your slides. Should be something here. Oh, Ian, over to you.
So thank you, Kostas. I'm just going to check to make sure that my slides go backwards and forwards.
Just click on it.
Okay, no, not yet. Try that screen. Okay, thank you very much. It's a pleasure to be here. I'm not an expert in AI, but feel free to ask me any challenging questions about AI, and I'll do my very best to answer them. I've got a broad background, and I'll tell you a little bit about that as we get to the appropriate slide. But so first of all, thank you, Kostas. Welcome to this year's Alastair Graham-Bryce Lecture. Alastair was an engineer born in Manchester. He's worked in a number of big organisations such as British Aerospace and Rolls-Royce, and he was passionate about engineering and the involvement of young people within engineering. And he said one of his greatest achievements in retirement was the formation of the Imagineering Foundation, which has worked very hard at getting young people involved in engineering, and he was one of the founders of that. My lecture today looks at our future world of AI and how that might impact our careers. There's one thing is the technology, but the more important thing, as we'll talk about later on, is what that technology does to our environment and how that impacts our careers, the world in which we're operating in. For those of you not in engineering, I think that this is just as applicable to non-engineers, but the presentation's been focused on thinking about young engineers and how that might impact their careers. I also think it's just as applicable to old engineers, which I count myself as one of them, because despite being in the latter part of my career, I don't feel I'm quite giving up yet. So let me tell you a little bit about myself. I'm a professional engineer. I've spent most of my career in aerospace and automotive, but have been lucky enough to work in a variety of technologies and with a variety of people in a variety of companies. So I feel really lucky to have had that breadth of experience. Before moving to a portfolio career, I was president of IMechE's Polymers and Composites division. That was 2,000 people working in the US, the UK, and China. So a reasonable breadth of experience there. Since then, I've worked in SME organizations, both as the CEO and as non-exec roles. And currently, I'm a non-exec director at the Manufacturing Technology Centre, and I also teach at Aston University on their degree apprenticeships, because I think those things I think are really very important and valuable. So we should be investing in that. I also am the CEO of a charity called Exevent, which was formed in 2020 in the middle of COVID, looking at how negative pressure ventilation, sort of a non-invasive form of ventilation by surrounding your chest with an enclosure and applying a varying pressure to that, could support people that needed breathing support in a way that the positive pressure ventilation, which requires you to be anaesthetized and a tube down your throat, can't really do. So not suggesting that replaces it, but it's a complementary capability. This lecture, as already been said, sorry, marks a transition for me to pick up the chair of the manufacturing industries division at the IMechE after Costas, who's done a great job of it. Thank you, Costas. So before we dive into this, AI, good thing, bad thing? What do people think? Who thinks it's a good thing? Ooh, okay, we've got a few. Excellent. How about a bad thing? Who thinks it's a bad thing? Okay. Why do you think it's a bad thing?
How do you think?
Oh, yes, absolutely. That's definitely true. Why do you think it's a good thing?
Well, the benefits will be better than or outperform the bad things, probably. I hope so.
Me too. No, absolutely. I mean, certainly it's one of the biggest things that's happened to us. Whether you think it's a good thing or a bad thing, we've been absolutely obsessed with it for a very, very long time. Here's just a few of the films that have got AI in. Metropolis in 1927. I'm not that old, so I didn't see the original one, but I have looked at excerpts of it at YouTube, and it's quite interesting. 2001: Space Odyssey with the infamous HAL. I don't know how many of you have seen that film, but it's really worth watching. It gets a little bit weird at the end, but anyway. Westworld in 1973 with Yul Brynner as the gunslinger, and more recently a TV series in 2016 that really explores how AI could really change the world in which we live in. Blade Runner 1982, Terminator 1984, and I think 5 sequels to Terminator. And then Ex Machina in 2015, which I thought was really, really good. Have I missed anyone? Has anyone sat there thinking, "No, hang on a minute, what about this one?" And anyone know any other really good AI films?
The AI one.
AI, yes, yeah, and I think there's that iRobot. That's another one, I think, and Minority Report. That's a really, really good one. I really enjoyed that. And Bicentennial Man, you remember that? Where this is a robot turning into kind of a real person. Yeah, Chappie, excellent. So, we've been thinking about this for an awful long time, haven't we? So when we talk about AI, what are we really talking about? It's often useful to start with a definition. And this is a definition from IBM. Artificial intelligence, or AI, is technology that enables computers and machines to simulate human intelligence and problem-solving capabilities. There's lots of definitions out there, but I thought this was pretty good and kind of sums it up really. But AI, we tend to use it as an umbrella term for a whole raft of different things. So people talk about AI when they talk about robots. You know, there's machine learning, deep learning, fuzzy logic, speech recognition, generative models, computer vision, all of those things. People talk about AI in the context of all of those things, and probably a bunch of others that I haven't managed to list. But how have we actually got here? You know, how is AI even possible? Well, if we put to one side the kind of algorithms, and we won't talk very much about algorithms, but we will talk a little bit about how some of it works. But progress has been made possible by, you know, the improved capability in terms of processing, you know, the speed of computers, the speed of transmission, and the capability and the cost of data storage. And yeah, without those things, it really wouldn't be possible. So if we look here, I don't know whether any of you remember the Amstrad 2026, 2286, I think that one is. But that was, I remember having that as one of my first home computers. But this is a graph about supercomputers and their relative speeds. And the one at the top, is the Intel Touchstone Delta supercomputer, and I think that has a speed of 32 gigaflops per second. That's 32 times 10 to the 9 flops per second, which is 100 million floating point operations. That sounds like quite a lot, but that was back in, you know, the early 1990s. The one to the right there, that is the Intel, that is the Fugaku supercomputer in Japan. That's got 977 petaflops, 1 times 10 to the 15, so 1,000 million floating point operations per second. So you can kind of see that's really kind of a massive growth. And don't forget, on this graph, I've shown it as an exponential scale. So that's not linear, that's exponential. So it's kind of really impressive what's been done. If we look at the processes themselves, originally everything was linear. You know, one operation followed by the next operation. You can really see that, you know, that's going to be slow. And, you know, to be frank, it was. The development of multi-core capabilities, where you've got multiple chips within the same computer, that allows us to go much faster, allows us to do parallel processing. And interestingly, graphics processing units, which you know, many of us kind of remember as a separate card that you would plug into your desktop as you were building it. They turn out to be really good at doing processing for artificial intelligence. They can do lots and lots of similar operations very, very quickly. They're not as powerful in general as the CPU, which is the driving chip of most computers, and they generally don't have as much memory around them as the CPU. But for some reason, you know, with that particular capability of how they operate, they're really, really good at processing for artificial intelligence. And I don't know whether any of you remember NVIDIA as one of those companies that used to supply these graphics cards that you used to plug into your motherboard. But NVIDIA now, they've just passed $3 trillion capitalization, making them the second biggest company, floated company in the US next to Microsoft. So that's how big the impact of the graphics processing capability is in relation to the value of that company, because that company now really pretty much concentrates primarily on artificial intelligence now. And it used to be one of many people that supplied graphics cards, but they recognized that opportunity and have kind of shifted their focus to deliver against that. Memory and storage. I don't know whether anyone here remember the 5.25-inch 360 kilobyte 360 kilobyte memory storage. Some of you may even remember the tapes that you'd spend 10 minutes loading, and then in the last minute it would crash and you'd have to start again. So it's all kind of got better these days. I can get a oops, I shouldn't be touching that. I can get a USB stick for 1 terabyte for about £80, I think, and for £180 I can get an external hard drive with 10 terabytes. I mean, it's just massive amounts of data that that is transformational in terms of the ability to deliver in an AI world. The other thing that's been important is transmission speeds. So it's all very well being able to process quickly and be able to store it, but we've also got to communicate with things. And a lot of the Industry 4.0 stuff is all about communicating, about sharing information. And these days we share enormous amounts of information really, really quickly. Again, some of you may have shared the traumas that I had, downloading from my Nokia mobile phone at 0.2 megabits per second, I think, onto my laptop when I'm on holiday, my emails, which would take about 40 minutes, and normally 2 minutes before the end of it, it would tell me that it's had a fault and it's all crashed and I've got to do it again, normally about 11:30 at night. These days, you can get enormous amounts of memory, of transmission speed. So I think you can get, this is the BT system. I think, through my BT system, I can get 900 megabits per second, which would take about half a second to do the download that I did in 40 minutes. Well, I didn't do it in 40 minutes because it kept on crashing. So again, a massive element in terms of even just the enablers, the ability to create artificial intelligence. If you add all those things up, that's really facilitated a growth in the use of the internet, the use of data, and you can see here the steady growth in the number of users of the World Wide Web. And this was 2018, where we had just under 3.9 billion people. Today, according to Statista, there are 5.4 billion people using the internet out of a global population of just under 8 billion. So that's well over half now. And most of those are using social media as well as other things within the internet. I don't know about you, but certainly from my own experience, that's the number of people. But I think, the amount that people are using it is increasing massively as well. So I certainly am spending an awful lot of time on my phone when I should be concentrating on the people around me. Everyone I know is doing that too. So I think actually if you add in the multiplier of the amount of time people are spending on it, the impact is really even bigger than that. What that gives us is a massive increase in the amount of data that we can train AI systems on. An AI system's absolutely no good unless you can train it. If you've got very limited amounts of data to train an AI system on, then it can do just that, very limited amounts of things. If you've got enormous amounts of data that you can train an AI system on, it can do lots of really, really clever things. And that's why I would say that just in the last couple of years, the thing has just suddenly taken off, because the volume of data, the speeds, the processing capability, they've all come together to make something that really now, for the first time in its journey, actually really, really can work for us and can really make a difference. So let's explore a little bit more about what artificial intelligence is. We've all heard, I think, of machine learning. That's my best attempt at showing a learning machine. You'll notice probably, if anyone knows my artistic capabilities, that I've not designed that myself. I've just gone into ChatGPT and asked it to draw me a picture of a machine learning item, and this was one of the many things it came up with. Machine learning uses an algorithm that's trained to get better at tasks. It tends to be quite specific tasks, and it tends to be kind of programmed largely by people. So there's a number of different ways in which you can train it. There's supervised learning, where basically, if we think about apples, tomatoes, carrots, if I show the algorithm pictures labeled, oh, this is an apple, this is a pear, no, this is a carrot, this is a tomato, and I show them enough of it, it trains the AI, in this case machine learning, on what those things are. So then when I say, what's this? There's a pretty good chance that it'll tell me it's an apple. Unsupervised learning is slightly different. You share loads and loads of data of pictures of apples and carrots and tomatoes, and you don't tell the AI what they are. But through the analysis of it, it works out what things are similar, what things are different, and it ends up being able to group them so that it knows that this is one group, this is another group, and this is another group. But if I look at the group of apples, the AI or the machine learning program has got no idea that that is an apple. It just knows that that's a group of things. And you can then connect that to say it's an apple. And then finally, you've got reinforcement learning, which is where you show it a picture, you show it a picture of a tomato, it says it's a carrot. So you tell it, no, it's not a carrot, it's a tomato. Next time it sees a picture of a tomato, it's got a better chance of saying it's a tomato than saying it's a carrot. And do that multiple thousand times, and you end up having taught the machine learning to recognize these things. Because when you've been on your computers, has anyone, to prove that you're a human being, been asked to identify everything with a lamppost in it, or everything? Yeah, so yeah, this is free training for a machine learning or an AI bot. That is what they're doing. They know that you're not a machine, or they might know, but they don't really care. All they're interested in is you giving your time for free to train their machine learning item. That's what's going on there. You still have to do it just because you know that it's just free effort. You still have to do it, otherwise they don't let you into the program. Deep learning. That's another one of the words that we hear when we talk about AI. What does it really mean? Well, deep learning is it's a processing activity. It uses multiple layers, and it's kind of using a neural network. And when I talked about having multiple processes, that kind of allows us to have multiple points that are analyzing things at the same time. Well, a neural network is using kind of a similar approach, analyzing multiple things through different points. It's actually pretty much how the brain works. And it really was the brain that kind of inspired people to think about using neural networks as a way of processing. Clearly, you can see that it can process far, far more data than a linear program. And again, this is one of the enablers of the capability of AI that we're starting to take for granted, I think. So having got our deep learning and sort of building on natural language processing, which kind of as the name suggests, is about analyzing the words that we use, how we use them, the interrelationship between those words. Once you start to take that capability, think about massive amount of data being fed into it, think about the analysis being able to evaluate the interrelationships, you start to be able to train what they call a large language model. And the benefit of a large language model is that, well, language is the thing that we use all the time, isn't it? And, in order to make these sorts of systems usable, it's important to transition from something that was in a computer, and maybe you've got to learn how to do Python and, and use, programs like that to interrogate it. And then you've got to work out what the answers really mean. Instead, you can ask the question in words that we all recognize, and it'll give you answers in words that we all recognize. And you can pick whichever language you want it in, and a whole raft of other things. So these models are taught on a whole raft of things. They're taught on books. I'm pretty sure they've all been through, all of Shakespeare's plays, whole raft of different books. Almost everything in the internet. I think most of the free systems are probably trained on the internet up to a couple of years ago. So just think about the amount of data that's in there. It's just massive. And if you want up-to-date stuff, like in the last 6 months or whatever, you can pay extra. You can get the up-to-date bit. So they've already worked out how they're going to get your money off you to make use of it. But it's very impressive what can be done through it. So OpenAI's large language model is the thing that powers ChatGPT, and ChatGPT stands for Chat Generative Pre-trained Transformer. So chat, fairly obviously, generative is that it's coming up with new things rather than just regurgitating things that you've already told it. Pre-trained, because you've dumped a load of data in it and asked it to evaluate it from the internet and a whole raft of different sources, millions and millions of photographs, audio, whole raft of stuff. And then Transformer is a piece of software which is neural network driven, which basically takes your question, which might be what colour's the sea, feeds that into the large language model, allows that to work out how everything relates to it, what might be a good answer to that, and then takes its response and turns it into the output, which might be the sea's green. So while I'm not trying to teach you everything about AI, first of all, I don't know everything about AI, but I'm trying to give you some of the building blocks so that you can see how the layers kind of build up to how some of this works. Any of you that is working currently in AI, you'll know there's a lot more to it than this, but there is a limit to how far I can go with it. So let's think about some of the benefits and drawbacks. Well, one of the benefits, it's guided by humans. We have a big distrust if we don't understand how things work. Machine learning is comparatively simple. So we're helping the algorithm, we're training that algorithm. It's humans doing it largely, and that kind of means that we can see almost the connection between how it's being trained and the humans involved in that, and the sorts of outputs that it can create. As time goes on and it does more and more, it gets better and faster to the point that it'll be better and faster than the person that's trained it or the people that's trained it. It can get to the point where it can see complex patterns that maybe we can't, because it hasn't got the kind of limitations in terms of overload that we might have. It's generally modal, so it's trained on a single type of data. So it might be words, it might be pictures. So it tends to be for quite a focused task, but it doesn't have any sort of independent review. It doesn't know what's right or wrong. It doesn't have any frame of reference to look at anything in. So if, as an example, the information that it was trained for has got human bias in it, and almost all of it does have in one form or other, then that human bias will go through to the machine learning. And so, you'll get an answer. It could be right, but it might not be completely right, and it might be missing important things, and it might be pointing to things that are not as balanced as we really want them to be. Lots of similarities with deep learning, but deep learning can be put to a much wider range of activities because of the speed that it can do it. It doesn't require the human intervention that machine learning generally does, so it can be used in a much wider range of applications. The training for deep learning can often be multimodal, so pictures, words, sounds. But it does need a very large data set. In order for it to be effective, you need lots and lots of data for it to analyze in order for it to be able to do something. It can be really reliable and repeatable. It can be really good at what it does. But again, it's got no moral compass, no compass at all. So the answers it gives you might not be answers that are acceptable. And again, you've got all the bias of the things that were used to teach it. That's going to come out in the outputs. So unless you've got mechanisms of working that out and detecting it and counteracting it somehow, then that bias is going to be perpetuated into the future. And also, we're now at the point where it's really quite hard to get our heads around it. So I can kind of understand an algorithm where it's kind of, it's working through the algorithm, it gets some feedback to get better at it, and in that process gets faster and faster. Now suddenly, we're chucking enormous amounts of data into a neural network of multiple layers. We're kind of getting beyond my ability to visualize and understand what's driving the decision making. So so as a result, there's kind of distrust potentially in that decision making. At best, there's just this lack of understanding or lack of knowledge about how discrete decisions are arrived at, because it could have come from so many different directions with everything that's been put into the training. We think about large language models. A big benefit is that we can start using normal spoken language. Most of us are not experts on IT. Most of us cannot program in Python, or most of us cannot even program in BASIC. And as a result, it becomes so much more useful once you can interface with this in our natural language. And that's a really powerful element. Again, for large language models, the data can be multimodal. When it's multimodal, it's called a large multimodal model. So I'm kind of mixing my models up slightly here, but the principle's the same. Again, it needs a large data set. The outputs can be completely wrong. So if you're asking it to write your essay for your next assignment, it'll actually give you a pretty good first draft, probably. Not that I'm ever suggesting you do that, unless you've been allowed to do it as part of the course. But there's every chance that there will be things in there that are completely wrong. So do not rely on this to get your work done. It's a great start, but you need to go through it, you need to rewrite it in your own words, and you need to validate what it's saying. You need enough knowledge to know whether this is right or wrong. And if you go, because it'll also generate your references and all this sort of thing. If you go and check your references, you'll find quite a few of them don't exist. They never existed. It's completely made up. Now, feels like a bit of a weakness. Perhaps it should have said, no, I don't know. But actually, if you plug it into ChatGPT or whatever, then you will get what they call hallucinations, things that are just completely wrong. So, we have to be really quite careful about that. Again, no compass. And now we're starting to get into the regions where we really can't get our heads around what's going on. And over time, that does become a bit of a problem, because if we've used all the knowledge of the really clever people around us that are real experts in this area to build the models, and if we're not retraining the next generation of people as experts in those areas, we end up with a position where no one can actually check whether the output is right or not. So we need to be a little bit careful. So machine and deep learning are examples of reactive limited memory systems. They exist within the moment, within the boundaries of what they've been created for. They can't go outside of that boundary. The ultimate aim, or perhaps fear, is theory of mind or self-aware machines. These are called artificial general intelligence, and they kind of create a digital model of the world, their surroundings, the things that they interact with, how they sit within that. And in theory, they kind of understand to a totally different level what's going on. The way you train that, the way you set the objectives for that, really massively important. And this is the thing that is kind of driving almost all of those films that we saw on the screen earlier. This is the driver to the concern and the thought process around Terminator, where the machines take over and destroy the humans in the process of doing it. So this is the bit which is really interesting. I'd say. I mean, what's happened so far is just fantastic, but this is kind of the tricky bit, I think. And some people might say that we're there already, but let's carry on. So how do you tell if you've got intelligent machine? So Alan Turing back in the 1950s came up with a mechanism for doing it, which has kind of been for a very long time the recognized way. Basically, you get 3 players, you get the machine, you get an interrogator, an evaluator, and you get another human being. And they're then separated by either being in different rooms, or maybe they're in terminals in different locations. And the evaluator starts asking questions to both the machine and the human. And the evaluator responds to those answers, follows up with other questions. And over a conversation, the evaluator's got to work out whether they can tell which is the machine and which is the human. The answers don't have to be right. This isn't a, how right are you question. This is a how human are you question, which is perhaps not necessarily the best definition of intelligence per se, but it is the driver of that test. If the evaluator can't tell reliably which is the machine and which is the human, then it's said that the machine is intelligent. There are lots of other tests, variations on a theme perhaps, but if you start thinking about what we talked about artificial general intelligence and its ability to understand its context, other players in the environment, etc., maybe we need something that's a bit more broader to work out where we are in terms of whether something is intelligent or not. I suspect we're probably already at the point that the evaluator often cannot tell the difference between a computer output and a human output in some areas. So, how does AI relate to the law? The challenge for us is that AI moves really, really fast, just like the internet, just like computing in general, really, really fast, and the law moves really, really slowly. So there's very little chance of the law getting in front of the AI. One of the challenges is, this is a complex area with lots of experts. A lot of the experts won't agree on things. That's what experts are there for, to have different views and to debate it. So how do you get to a common view as to how you should control it? This is really challenging. There's lots and lots of different elements that need to be brought together. So that is an issue. There's issues around intellectual property. If AI creates something, who owns the intellectual property for that? How do we know that the AI didn't use somebody else's intellectual property in creating it in the first place? So we've got a bunch of challenges associated with this. Copyright, publicity rights. I put that up because of this is about voice, and some of you might know that Scarlett Johansson has been complaining to OpenAI that they've been using her voice, and so that's a publicity rights. Liability. If an AI-driven controlled car crashes into something, who do I sue? So all of these things are really challenging. There's a new EU law as of last week. It will apply to the UK because most companies interface with Europe in some form or other. So and at least it's a starting point to think about how to control some of this. AI really also helps criminals. They use chatbots to increase the number of people they can attack. They can use social media. AI can scan it and identify data about you that you put on social media, put it into automatically an email to you that has got enough information to make it credible, and to try and get your bank details or whatever. Recently, there was a CEO of a UK-based energy company had his voice impersonated by AI, and that company lost $240,000 as a consequence of that. So, this is a challenge. On the other hand, it can help in crime prevention. So AI has been used to analyze millions and millions of documents in, as an example, fraud cases. So this is a case where Rolls-Royce was charged with fraud in terms of how it interacted with foreign customers, and there was so much information that a human team would never have been able to have found the evidence. But working with a company called Raven, they were able to analyze millions of documents, and as a result, highlight the connections in a similar way to a large language model might highlight the connection between words, and then push forward from there. So thinking about the benefits, smart decision-making, automation, lots of opportunities in medical, faster data analysis, reducing human error, particularly when you connect it to robots or various forms of automation. But on the other hand, probably the most important thing on here is that it will change things. It's, any industry you're in, it's going to change. So don't think that, you're an expert in this area and you're safe because, it's not going to come to you. It's already here. It's going to change it. Roles that exist today, might not exist in the future. Roles that don't exist today will be created because of the change of technology. The important thing is to respond to that, to know enough about it to be able to move forward and to react to it. How do you deal with that? Well, have a go. So who has not yet had a play with AI? This isn't a judgmental question. Good. I'm really pleased. Last time I asked the question, about 25% of the audience put their hands up and said they hadn't played with AI. It's the best way of starting. Have a play with it. Get to understand what it is. One of the key things is, it's only as good as the data that you train it on. So, think about the context of how you can use it. Check to make sure that in your work environment you're allowed. If you're not, then learn about it at home. But do not use your work information. Do not use work data in that, because as soon as you put that work data into the ChatGPT or whatever it is, it becomes part of its data set. So it's now out in the world. You've lost that. And if it was protected, if it was important for your company, now it's available to everyone else. As I say, don't use it to write your assignments unless you've been asked to write your assignment. I think universities will have to change how they approach dealing with AI. In the future, AI is going to be part of people's jobs. They're going to use it all the time. In universities, I think we're going to have to learn how to have that as part of the curriculum, have the use of it as part of the curriculum, and make sure that we use the right techniques to determine what people's real capabilities are. So there are lots of things that it can do. There are benefits, there are risks, but whatever happens, it's here. It's not going away. So you will be better off if you put effort into understanding it, understanding how it works in relation to the things that you need it to do, understanding what controls you might need to put in place, and develop that knowledge over time so that you can use it effectively and not fall into the trap of thinking it can do this and getting exactly the wrong answer with a hallucinatory response to it. Kind of moving on a bit more to the career focus bit. In terms of careers, there's some basics that are fundamental to long-term success that have got nothing, very little at least, to do with technology. Individuality. We're all different. I look around this room, we all look very different. We all talk very different. We've got different accents. We've got different backgrounds. It's really important that you tune things to yourself. Develop a plan around your career that relates to your strengths, your weaknesses, the things that you want out of it. So don't just take an off-the-shelf plan for someone else. Tune it to make it work for you. And rejoice in the differences. Rejoice in the things that make you different, because they're the things that allow you to look at things from a different angle and perhaps come up with solutions and answers that other people in the rest of the group might not. So this is a really powerful thing. Celebrate it. Kind of don't just blend into the background and try and be the same. Be yourself. Integrity. It's kind of really, sometimes there are some difficult decisions that you've got to make. Integrity is really for you, not for anyone else. I mean, people have a view about your integrity, but ultimately, the most important receiver of your integrity is yourself. It's how you feel about yourself. Do you feel confident that you are happy with the things that you do. It gives you the confidence to go into difficult environments and know that you can make the right decisions and stand behind those decisions effectively. In this world where we can make deep fakes, and so we can create a video of me saying something completely different to what I've just been saying, and no one can tell the difference. Your integrity, actually is one of the few things that can defend you against those things. If people know you and the things that they're suggesting you're saying, they know you wouldn't say, that at least helps in that process. And in today's world of social media, where there are plenty of people out there that just seem to delight in saying terrible things, if you are solid about your own integrity, it kind of provides you a bit of a personal barrier to the challenges of what is quite a tricky world. Taking ownership. So, as you can tell, I've been in industry for quite a long time. I've been in lots of different jobs. I've been in lots of different environments. And you often see, when you look at teams and things happening, you often see real cores of people where, enormous amounts of decision-making and activity and success comes from that small core. That small core is often surrounded by lots and lots of other people. Lots and lots of other people are just there. They're not necessarily doing anything. The ones that are making a difference are the ones that take ownership. The ones that don't leave while the job is half finished. The ones that make sure that things get sorted. And when they go home, they're happy that they've left it in a good state. The ones that are happy to just walk out in the middle of it because it's now, at a particular time, and that's the time they always go. This is a challenge because, people that that really drive activity, drive success, are the people that own a problem, stick with it, work with it, turn it into, a problem turns into a solution and a positive future. Education and training. I'm still learning. I've been learning for a very long time. I hope I'm going to carry on learning a lot more. I've been learning, in the last few years, more and more about AI and other things. It's a fabulous opportunity to be in places like this at Cranfield University, where there are enormous opportunities to learn. You can learn through short courses. You can learn through things at the IMechE, at the IET, a whole raft of things. What I'd say is, always be thirsty for this. You never know when these things are going to be of value to you. So, if you see something interesting, find out about it. Spend a bit more time. Build up your capability. For me, it's not about how good you are at something per se. It's about how can you deal with the things that keep changing around you. And the thing that protects you in that environment is having a wealth of understanding, a wealth of experience. So really be thirsty for knowledge. As an engineer, you'd probably be pretty familiar with the CPD cycle: goal setting, benchmarking, planning, recording, reviewing. It used to be kind of just expected of us to be doing CPD. Now it's kind of more required of us. And there are various processes that can record that, etc. Again, I'd say, use it as an opportunity. What you'll probably find is that most of you are doing most of the things that are required for CPD, but you're not necessarily recording it. So, take the opportunity of recording it. Actually, it's quite interesting when you put it down in writing, whether it's on a computer or whether it's on a piece of paper. Suddenly you realize how much you do. And things like this are really, valuable things that go towards it. Who's ever managed people in here? It's hard, isn't it? Say in my career, it's the hardest thing I've had to do. But it's really, really valuable. The skills you develop are really, really important to your success. Very few people can be individual contributors to the scale of their real capability. By working with a team, by having the leadership skills of working with people, you can create so much more than you can on your own. and you can influence things so much more successfully. And, I'd say, it is the hardest thing you can possibly do, but there are a few things that kind of help. First of all, be honest and straightforward about things. People are really clever. So if you're trying to hoodwink them, if you're trying to persuade them that black is white, you're not going to work. So be honest, be straightforward, deal with the issues in front of you. Lead by example. If you're going to walk past a coffee spill, then everyone that works for you and everyone that works sort of around you, they'll see that you've just done that, and you've just said to them, that's not important to me, which means that it's not important to them. So the next person that walks past it might not quite see it, might slip on it, break a hip, and actually that's your fault because you walked past it. So lead by example. These things are really important. When you've got difficult things to deal with, don't wait. Don't let it fester. Don't let it get to get worse and worse over time. Address it early on. Talk about it openly. The sooner you address these things, the quicker you can deal with them, and the better the resolution. And don't deal with these things emotionally. Deal with them with facts. Be supportive, but straightforward. It's not about being soft. It's not about being tough. It's about being honest and dealing with the facts. And if you build up a reputation that you're fair, but you will deal with things, that's a really strong reputation to have with building with people. Lots of engineers use project management or program management as a transition out of the pure technical world into the non-technical world, into the leadership world, into senior management, etc. It's a really good way of doing it. And if you're interested, I definitely suggest you find out more about it. Just be a little careful. Most people, most of the time, are pretty straightforward and they'll tell you what they're really thinking. If your project is risking damaging something that someone else values, whether it's damaging their status, their reputation, interfering with their club, they won't necessarily tell you that that's what's going on. And they might smile, they might be all really, I really support this project. And then they'll be spending all their time trying to undermine it subtly in ways that you don't see directly. So be really careful. People are driven by power, influence. You have to think about the dynamics of what's driving people's behavior. And they may not be looking at it from the same direction that you are. You're sat there thinking, this is logical, this is really sensible, it's obviously the good thing to do. They might be sat there thinking, this is a terrible thing, it's going to cause this problem, that problem. If you're in that situation, try and identify what's going on, try and identify who is struggling with the direction of travel, and see if you can engage in conversation, because you can't resolve it until you've actually worked out what the issue is. And by having that conversation, by doing it openly, and not necessarily assuming that your position is right, but trying to work out what the issue is and try and come up with a resolution together, you've got a fighting chance of resolving it. Who likes accounting? Yeah, I get that a lot. As an engineer, everything that you've ever done, an accountant has signed that off as being, yes, we can do that, that makes sense. If you don't understand the way they put the numbers together, the way they evaluate it, the way the key performance indicators are derived, and what your manager is being measured on, you will not understand the decision-making that happens in your organization. I'm not saying that it will answer all the questions, but if you can get your head around, look at, get involved in management accounts, start to understand the KPIs, what people are being measured on, then you've got a fighting chance of understanding what's going on. And in particular, I would say, really concentrate on, what KPIs are being used to drive senior people's bonuses, because it's amazing how effective you get what you measure. And, so if you're successful, if you deliver on that KPI, here's a lump of money, or here's a lump of promotion or success or whatever, those things are massively, strongly connected. So don't underestimate it. Seize the opportunity. You can't predict what's going to happen. Opportunities throw themselves at you. Quite often you might not realize, you might not recognize it. Grab them, really think about it. Think broadly, out of the box, because quite often some of the best opportunities kind of are not right in the mainstream of where you think they're going to be. They're really off to the tangent. Your first reaction might be, well, why would I want to do that? Think about it, consider it. You know, if it's a real opportunity, grab it. If you're going to learn from it, if you're going to increase your skills, grab it. And just be careful about how you do things. You need to put yourself forward. You need to be visible. You need to make a noise about what you've done, but don't tread on everyone in the way there. It's a very small world. We keep meeting the same people. It kind of comes back a little bit to integrity as well. You know, our behaviors impact the people around us. And, you know, we can drive the culture of an organization. If we behave well, if we are doing the right things in the right way, pretty much, you know, that sets the tone for the rest of the organization. And, you know, in the end, you've got to be satisfied yourself. You know, when you're reaching the end of your career and you're spending more time in the garden than you are in the office, you've got to be sat there thinking, yeah, no, I was okay with that. I was happy with what I did. You know, I feel good about it. You know, be careful about not finding yourself in a position where you don't feel good about it. That's pretty much it. I hope that was helpful. I hope that was useful. Now is your opportunity to ask me whatever questions you'd like. I will do my very best to answer.
Thank you very much, Ian. Any questions from the audience for Ian?
Yeah.
When you generate AI, how come it's still in this way?
Oh yeah, I don't know why. But quite often I've had to redo it multiple times, and yeah, like the integrity one. You know, that was about 10 attempts before it actually spelled integrity correctly. So, but that is kind of a feature of it. The other thing is it often comes up in multiple languages as well. You know, so again, I've had to say, no, can we have it in English, please? And then sometimes it will, sometimes it won't. This is the kind of, over time, it'll get better. I mean, over time, it learns from what it's done, the feedback you get, and it gets, you know, trained on bigger models. It'll get better, but that's the state of the art today, I think. There are a couple of questions back there.
Yeah, so let's say there is a problem in a manufacturing, which has been there for the last 5 years or 10 years.
Yeah.
As a production engineer or as a quality engineer, based on my knowledge, I've tried this context. I know where exactly the problem is happening, but I don't know why. Yeah, there's something called root to find a root cause. How can AI help me to find that root cause, given that I'll be the one who gives the inputs or outputs to that AI?
Yeah, so I guess for me, I'd say AI is all about data. And you know, we have a certain ability to analyze what we're seeing, but it's limited. We can't take in millions and millions of data points. So I would say, you know, if you've got a process that's got a problem with it, you need to think about what are you measuring, what can you measure. Start with what you're measuring, and I would say, you know, input that data of what you're measuring into something that has been trained to look at it in the right sort of way. So I'm not saying you necessarily have got something off the shelf you can plug it into. And I think, you know, what you'll find is, first of all, it'll look at interrelationships that, you know, that you just don't have the time to look at every interrelationship, but it can identify interrelationships. It can identify the strength of the cohesion between those two things, and it can start giving you indications that it might be a problem in this area, or it might be a problem in that. It might not be right, but it might be that 3 or 4 things down the list of things it comes up with is something that makes a difference. Over time, maybe you want to think, when you're designing the process in the first place, what are the things you want to measure? And then tracking those measurements over time so that you can spot if the control process is going out. Yes.
Just regarding the pictures, I don't think it's not just the spelling, but there is no a single picture that has something that damages my logical understanding of reality. For example, how someone will go into that building with the columns being all together.
Yeah, that have to be quite over the top.
during your talk, which was really interesting, by the way. I enjoy focusing on different aspects of the image. Now going to my question, no one nowadays, for example, here in the university is expected to do a linear regression of his data, or I don't see no one drawing technical draws and
Yes.
doing blueprints by hand, and we all use CAD, etc. So one of the policies here in the university is that you have to mention that you use AI, ChatGPT, let's
Yes.
say. But it's obvious that no one is going to ask you that, oh yeah, I use Microsoft Excel, or I use Word, the spelling check of Word in this document. In this transition periods between having the tool, which, by the way, in my opinion, is not good or bad, it's just a tool.
Yeah.
And when we reach that time of acceptance that we have regarding these other tools that I mentioned, how do you think is the most interesting way of navigating it? Because from my point of view, for example, I find if I'm using it ethically, I find silly having to tell you I use it, because it's obvious that I use it. It's a tool that makes my work better. So.
Yeah, no, I think you're absolutely right. Over time, I think it will, we'll probably be able to stop having to reference the fact that we've used it. But in this transition period, where it's new, it can be quite interesting in terms of what it can produce, and it can create. Sometimes it can create responses and answers that the students, A, don't understand, and B, couldn't get to themselves. In those environments, it's important to reference. I think eventually, though, I think it will, as you say, it will just be a tool, and we'll all be using it all the time, and people will just they'll be surprised if we're not using it. And there was a question up there, and I'll come back to you in a second.
But I'm going to be very used to do. But there comes a day where we have a Mona Lisa and we have an exact copy of it. Right now, we are not in the very exact copy. So yeah,
Yes.
analytical. This type of story is a meaning behind what Mona Lisa was and what the picture copy is. Do you think next 25 years will, as society, accept? Okay, yeah. This is a Mona Lisa's exact copy. You can show it, and this is good.
I think it's a really good question, and I think actually it raises the challenge of the kind of whole arts world. So you've got pieces of art, you've got pieces of music, you've got literature. AI can generate all of those things. Maybe actually for basic simple things where we're putting presentations together, maybe it's good, but maybe we don't really want it to be creating a Mona Lisa, and perhaps we don't really want it to be competing with artists that have put their own content in.
I want to ask that question because I want to say next part will be instead of Mona Lisa, engineering product.
Yes.
Engineering.
Yes.
Do you think we'll be doing that to engineering products in the future?
I think AI will be able to design engineering products. I think the way AI works today is that it can do a bunch of things, but normally before it turns into something real, there's a human validating what's going on. And I think we'll get to a point where we've got confidence in certain things. I think once you get to things like high integrity systems, I think we will have to be putting a lot more validation in before we start to use directly outputs from AI, because the consequences of a rudder falling off an aircraft with 600 people on it are pretty big. So I think there are some areas where we probably just use it, and the consequences of it not being quite as good as we thought, not really an issue. Other areas, I think we'll have to do massive amounts of validation. They're going to be really difficult to work through. Sorry.
Everybody's an expert.
Yes.
Because this is the critical any implementation where even nobody knows what kind of data you need. And then number of experts very limited. So how do you see it?
I think there's a couple of things. I mean, if you've got very limited number of experts and you can't use them necessarily to train the AI, you've got a constraint. On the other hand, the AI can derive stuff from itself based on physics, based on the data that it can get its hands on. I think there's a real question around how you use company data, university data, because at the moment, you know, these things are largely being trained on the internet. As soon as you're considering using university or company data to train things, you need to think about where that data is going. And can you keep that data in the environment in which you're using it and not allow it to go back into the wider model? And there are ways of doing that, but you need to proactively manage that. Otherwise, that data will just disappear into the wider model, and now everyone's an expert at it. I think there are some things where I think AI will, you know, quite scarily surprise us about how good it comes up with things. But I think, you know, in important areas, it's this validation bit. We need to validate, we need to check. And I do worry that there is a risk that we start to lose expertise. You know, that we need to be driving core understanding from first principles through to the complex outcomes. We need to have that knowledge within people so that we can make sure that the results coming out of AI are realistic, and a whole raft of other things. But we need to be careful not to take the easy route and lose that knowledge route, because ultimately, you know, we will get to the position, if we don't, where we don't know, you know, it's giving us an output and there's no one that can tell us whether it's okay or not. So at that point, well, we just accept it. I mean, you know, I kind of see that in the manufacturing world. I see it with ERP systems. People populate an ERP system, the people that populated it put in all these fences and timeframes, et cetera, and then 2 years later, those people have all disappeared off and they're all doing other things. No one's got any idea what's driving the outputs from the ERP system, because those people have moved on. Now, when there's a big problem, someone's got to, you know, get into it, unpick it, work out what's going on. And so, you know, when you hit a problem, you've got to kind of go backwards. I think it's really important we keep the knowledge capability moving along separately, you know, in parallel without losing that.
AI, still know that AI can't generate new ideas. Just be because it's all the ideas.
No, it can do new ideas. Generative AI can come up with things that you haven't thought of.
Personally, but still it's based on the information that's already there, just mixing, matching, and giving new.
Well, let me give you an example. So there's lots and lots of data about how metals react with each other. But there are so many different potential combinations of alloys that we simply have not had time to create each of them and test it and validate it. Whereas, you know, without 100% accuracy, AI can evaluate what a billion different alloys, how they might perform. And they can then say, well, we think, you know, we AI think that these are probably, if you want these characteristics, these are perhaps the 10 alloys you should try and make and then test. And that will massively increase your hit rate in terms of coming up with the right alloy for the application. So that's just kind of one area where, yeah, it goes beyond current knowledge. It drives on principles that exist and knowledge that exists, but we've not done it, therefore we don't know the answer. And there are so many opportunities, we haven't got the time or the number of people looking at it to go through all those opportunities. So this is a real, you know, sort of resource saver, but it is generative, it is creative in the way that it looks at it.
Questions still from the audience?
Most people when they talk outside, it's always talk
Yes.
Is there someone waiting to put it back?
So, how would you stop that?
So I think for me, the biggest concern about it is probably the way it could be used by malicious players. You know, again, its ability to try lots and lots of different things. If it's trying to break into a secure system, if it can try lots and lots of different ways to get into that, maybe it's going to find a way into something, you know, that we don't want it to. I think this is going to be a continual battle where the people protecting things are continually fighting against a constantly changing challenge. I can't say that it'll always be successful. If you think about the attacks on hospitals and on companies' IT systems from hackers, you know, they're successful, and then you find a way of solving it, and then it's okay until the next. This is a continual battle that I hope that the people that are in charge of the most risky things are right on top of. There was someone in the.
Let's take one more question from the audience.
Yes.
Well, my question is relative to the previous.
Yes.
You mentioned, or the narrative on that level is AI as a tool which can be used for good, can be used for bad, criminal,
Yes.
used. But how do you think? What do you think about the concept? The bigger concept comes from the movies that you showed, the Terminator, or even let's say people like Stephen Hawking. It can be a real threat, implying that becoming autonomous, disconnected with the human
Yes.
element,
Yeah.
driving them, but becoming autonomous and destroying the world at the end.
Yeah, I'm not worried that it's going to destroy the world. I mean, I think I think there will be issues, and we'll react to those issues and maintain a balance. I think, you know, ultimately, I suspect that, you know, to get to the scale of some of the films, you know, we probably need to put so much energy into that system that it would kind of, everyone would notice the lights would go dim. So I'm really not worried about it. But I do think there is a constant battle that we will have to have between, you know, kind of, you know, making sure we stay on top of what it's being used for, making sure we deal with malicious players, but also I think we do, from an environmental perspective, need to think about how far do we want to go, because ultimately this has the potential of using enormous amounts of energy, which could lead on to more greenhouse gases, you know, more of the environmental challenges. But we shouldn't ignore that. It is a non-trivial aspect of what is really quite an exciting area, I'd say.
Okay, let's take some of the online questions.
Yep.
So there is a question on how to start with AI. So basically, the question is that AI seems to be very broad. If one is new to it and wants to train, what would you recommend for getting started?
Yeah, so my recommendation in the first instance would be just try it. Go on ChatGPT, you know, ask it to draw a picture of a university with lots of questions. And you might get something like that, or you might get something completely different. Just try it. And you start to see that it doesn't give you quite what you thought it was going to give you. And you know, through that kind of work out what its weaknesses are. Ask it to write a report for you. If you've got a business report to do, you know, ask it to write the report. Then go through it and see what's right, what's wrong. Rewrite it in your own words and fix all the things that are wrong. So you get a bit of an understanding about it. Then once you've got some sort of feeling for what's going on, I would then say, you know, there are lots and lots of kind of simple guides to introductions to artificial intelligence. And I think you then start to be more directive about which bit of it are you trying to learn more about. So I would say, you know, experience it first, then work out where you would like to learn more about it, and then dive into the detail from there.
Thank you. Another question from Mike. What is going to be the best change from AI adoption?
The best change. Okay, so I think there's lots of areas where there can be some really positive things. If I had to pick one thing that I think could be really interesting, our society has become, much more layered. If you look in a number of environments, you'll see multiple ages, multiple generations within a family all living together, and that kind of how it used to be. These days, you'll often find, people in different houses, possibly in different parts of the country, possibly in different parts of the world, and suddenly we've got a much bigger challenge around older people and their quality of life. I actually think, the sort of robots that will chat to people that can, I'm always forgetting words. So when I forget my word, if I've got a little robot on my shoulder reminding me what word I should have been saying, then that's great. Yeah, I've got a relative that's got dementia. She forgets things, within 30 seconds of it happening, but she remembers things from 30, 40, 50 years ago. These things can be developed such that they are positively reinforcing the quality of life of people in those environments. It's just one example. It's not an industrial one, but I think actually it's quite, for me, I feel it could be quite valuable.
Thank you. Another question, which is a long one. So Lei says that he understands that AI application in industry and daily life, but nowadays lots of researchers apply the concept of AI in, for example, computational physics. The question is this really meaningful? Because he carries on by saying it's actually not possible to extract the physical meaning from the model generated by machine learning. So do you think it's meaningful to use AI in that concept? Context?
So we're probably getting fairly close to the limits of my capability and understanding, but I'll give you a view on it. I think it's there's probably value in it, but I think what you've got to do, just in the way as I was talking about the different alloys, I think you can use it to generate concepts and ideas, but I think you've got to go through a more fundamental process to validate those ideas and to underpin them.
Partial response to that also, with some regression problems, it can actually spit out. So instead of fitting a curve, you can fit a differential equation. There has been a lot of effort going to some people interpret the machine. That is not the way to deal with that. But an equation that we can interpret.
Fantastic, thank you for that. It's really good.
Yeah, great. I don't think that we've got any more questions. So again, thank you very much, Ian, for the very interesting lecture and the Q&A afterwards. One last round of applause for Ian, please. And
Thank
thank
you
you for joining this lecture.
It's been a pleasure, and you've been a great audience. Thank you.
Thank you very much.